Okay, this is problem number 7 from the midterm review, and it starts off, part 1, create a degree 3 polynomial function that has 3 distinct zeros. I just want to tell you that a cubic, because that's what a degree 3 means, is a cubic. A quartic is a degree 4, a quintic is a degree 5, and I don't know what you call a degree 6, but if you followed pattern, it would be quartic, quintic, sextic. I don't think so. But yeah, okay, so a cubic could look like this, which would have 3 distinct zeros, or it could look like this, which would have 2 distinct zeros, one there and one there, or even it could look like this and have 1 distinct zeros. Distinct means different, by the way, because actually this has, well, we're not going there. The distinct means different, so that's what we need. That's what we're going to do. That's what the problem requests of us. I love that eraser. Okay, so I'm just going to write a cubic and call it a day. Let's just say I've got some x cubed function, but I need those different zeros because right now x cubed equals 0 is a thing, but that's not what I want. I want to have, I'm going to make my zeros x equals +1, x equals -1, and x equals +2. And what factors go with those? Well, I'm going to have x -1 for the first one, because that would mean that x -1 equals 0, x equals +1. And my second factor is going to be x equals +1, because if x plus 1 equals 0, then x equals -1 right there. And my third one is going to be x minus 2, because if x minus 2 equals 0, x equals +2. So there I've got my 3 distinct zeros. And I have created a degree 3 polynomial function with 3 different zeros. So that part is done. And then my next part is the graph of the function should end. I'm changing that because I want to do it in pieces. The graph of the function should end on the right in the 4th quadrant. All right, you need to be completely clear on the 4th quadrant. So that's 1, 2, 3, 4. And here it is. I'm going to use my graphing calculator and turn my graphing calculator on with my mouse. So this is a different example of this. So I'm going to input it like so. Oh, hell, do I want to do that? If I was going to multiply it out for you just to see what it looked like, I don't have to do this, but what the heck. If I was to do x plus 1 times x minus 2, glitter, I'm going to get x squared first, outside, inside, minus x minus 2. All right, then I would have to multiply that times whichever one I didn't do, which would be the x minus 1. And then I'd have to distribute everything. I'd have x cubed. That'd be x minus x squared, x minus 2x, and then the -1 minus x squared plus x plus 2. Combining like terms, I should have, if I didn't make any mistakes, x cubed minus 2x squared minus x plus 2. So that's another way of writing this. I mean, they're the same exact thing, again, with the codicil that I didn't make any mistakes, but I can enter it just like it is with my mouse. So I'm going to write open parentheses x minus 1. And the reason I'm typing it in is to see where it begins and ends. And remember, a cubic, a positive cubic, okay, I get confused. Am I facing the wrong way for you guys? I can't even think. I have to turn around to be unsure if I understand. I think that's a positive. I'm not sure. All right, yeah, that's a positive cubic, and that's a negative cubic. So where would it begin and end? If you can do it in your head, great. So I've got x minus 1 times x plus 1. Some people can do those kind of things in their heads. you would have to have very good spatial awareness. X minus 2, close parentheses. All right, so that is exactly what I got typed. Okay, good. So then I'm going to graph it, and I'm going to look at it, and I'm going to say, oh, it's a positive cubic. What does it need to do? It needs to end on the right. It does end on the right. It does not end in the fourth quadrant. It ends in the first quadrant. How do I change that? There's only one way to change it. I'm going to make it negative. So how am I going to make it negative? I'm going to multiply by -1. So that'll be here. I'm going to multiply by -1. And I can just type that into the calculator, or I can distribute the -1 to prove to you guys that it still works, because I'm just going to distribute into here. So now I've got -x plus 1. And the reason I did that was to make sure I still have the same, this will be the same, and I should still have the same solutions. The solutions should not change. And what I've got there is -x plus 1 equals 0. So -x equals -1 and x equals +1, which is what I had up here, x equals +1. So it's all good, that's fine. Solutions stay the same, but now I've got a slightly different graph. So I'm going to call back Wabbit, and I'm going to go to y equals, and I'm just going to insert a negative there. There is an insert button on your calculator. Second, delete, make that negative, and then this should be positive. And then when I graph it, there we go. This thing ends on the right in the fourth quadrant. So I've done what I needed to do. My solutions are still the same, and I have created my third degree polynomial. So let's see what else I need to do. Okay. Write the function in factored form. I already did that. It's already written in factored form. Goody. Describe the graph by identifying the zeros, giving the domain of each interval, and stating whether the function is positive or negative on each interval. Okay, that's all one giant thing I still have to do. So I'm going to have to do all of this. Domain of each interval and saying whether it's positive or negative on each interval. And looking at a, that was not going to work. Looking at a graph of just theoretically some cubic, we'll call it here, okay? Let's just say that that was -4. All right, so it's positive everywhere it's above the x-axis. So this thing would be positive from -4 to infinity, because all this piece is above the x-axis. That's all positive. And it would be negative when it's below the x-axis. So that thing would be, oh shoot, to infinity. And that thing would be negative from -infinity until, and you're going to explain it on the domain, which means the x values. That just says use your x values to talk about it. And whether or not it's positive or negative is your y values. You know, is it above the x-axis? When y is greater than 0, it's above the x-axis. When y is less than 0, it's below the x-axis. That's positive, that's negative. So in the domain is your x's. So this thing is positive, or y greater than 0 from here to here. And this thing, by the way, I just made this function up. If you're wondering where the hell did that come from, well, sorry, I just made it up. And it's below the x-axis until -4 and including -4. Okay, yeah, wow, that's tough. I will ask you to use this notation, because -4. Ah, my bad. This has to be a soft bracket, because -4 is at y equals 0, and that is neither positive nor negative. 0 is non-negative. So these have to be open brackets. I won't hurt you on that if you didn't watch this video, but if you want to be good, you should know that 4 does not get included in negative, and x equals 4 does not get included in positive. It's neither. So soft brackets. Okay, so we don't care about that because you want to finish this problem. And I want to do it a little faster in this. So we've got our graph, and we've got our zeros at +1 and at -1 and at +2. And just to make sure I'm clear on what it looks like, it's going to go like that. All right, maybe not exactly like that, but you get the idea. All right, so where is this thing greater than 0? Well, it's greater than 0 positive from here to here and from here to here. So I'll just write down those domains. So y is greater than 0 for -infinity to -1. I won't kill you, union, and don't worry about it. +1, all soft brackets, to +2. You don't have to write the positives. I don't even know what I'm thinking. And y is negative from here to here, and from there on. There should be an arrow there. So it's negative from -1 to 1, and from 2 to infinity. I wanted to say negative infinity because it's going down, but in the x direction, it's approaching infinity. So that should do it. That should be your last piece. The pieces that you need to answer your questions are: you created it, you wrote it in factored form, you defined it positive, negative, and just teaching moment, be aware that it's decreasing when it's going down and increasing when it's going up, and decreasing when it's going down. Okay, any other questions? Let me know. As I figure out how to quickly turn this thing off. Someday I'll be fast.